All right, welcome to the Explainer. Today we're going to break down something absolutely fundamental for your pharmacy exams, and that is the suppository base. So let me ask you this. When you think about a suppository, what's the single most critical part? You might think it's the drug, right? But actually, it's the vehicle, the thing that carries the drug.
You got it. The base. It's the foundation. It controls pretty much everything. How stable it is, how the drug gets released, and whether it actually works in the body.
Okay, so here's our game plan. We'll start with the role of the base, then what makes a perfect base, we'll classify them, talk about how to make them, run through the quality control tests, and wrap it all up with the key stuff you need for your exams. Let's get into it.
First things first, what is a suppository base really? What's its main job? Let's define this vehicle.
Think of it this way. It's got to be solid enough to handle at room temp, but once it's, well, where it's supposed to go, it has to either melt, soften, or dissolve at body temperature to release that medication. Simple as that.
Okay, so before we dive into the actual types you'll see in the real world, let's build our perfect suppository base. What would it look like in a perfect world? This is like our blueprint.
Now this list right here, this is pure gold for exams. These are the benchmarks we measure every real base against. Things like melting at body temp, being non-irritant, that's all super important. But check out that last one. It has to shrink when it cools. Why? Well, it's so you can actually get the thing out of the mold in one piece. Super practical and a great exam question.
All right, so we have our ideal blueprint. Now, let's get into the nitty-gritty and classify the real bases out there. They basically fall into three main categories based on what they're made of.
And here they are, the big three you have to know. You've got your oleaginous or fatty bases, your aqueous or water-soluble ones, and the emulsifying or synthetic bases. Let's break each one down.
First up, the old classic, the one everyone thinks of, oleaginous or fatty bases. And the superstar example here is theobroma oil. You probably know it as good old cocoa butter.
So cocoa butter is interesting because it's a great example of pros and cons. The melting point, almost perfect, right around 30 to 36 degrees Celsius. But, and this is a big but for exams, its major flaw is something called polymorphism. Basically, if you overheat it, the fat crystals form in a wonky, unstable way. And this unstable form melts at a much lower temperature, like 24 degrees. That means your suppository would literally melt in your hand. Not ideal.
Okay, moving on. Our next group takes a totally different path. These bases don't melt. Instead, they dissolve in the body's fluids. It's a completely different mechanism for releasing the drug.
The key term to remember with these aqueous bases is hygroscopic. It's a fancy word that just means they love water. They're like little sponges pulling moisture right out of the air. This is a big deal for two reasons. One, you have to store them carefully, and two, because they draw in water, they can actually dehydrate the surrounding tissues, which can be, well, pretty irritating.
And that brings us to our third category, the emulsifying or synthetic bases. Think of these as the problem solvers. They were engineered specifically to get around the issues we saw with natural bases like cocoa butter.
So synthetics like Widipsol have some awesome advantages. They set fast, you don't need to lubricate the mold, and you don't have to worry about that whole polymorphism mess. But they have their own problem. When they're melted, they're not very viscous. They're kind of thin and watery. This means the active drug powder can just sink to the bottom of the mold before it solidifies. And that is a huge problem for getting a consistent dose.
Okay, so we've picked our base. Now what? How do we actually turn this stuff into a suppository? Let's check out the main ways it's done.
There are three main methods you need to know. First is hand molding, the old school way. Then there's compression molding, which uses pressure. And the one you'll see most often in large-scale production is pour molding or fusion. That's the one where everything has to be super precise.
And speaking of pour molding, this is what you'd use. It's a classic suppository mold. You just pour the melted mixture of the base and the drug into these little cavities, let it cool and harden, and boom, you've got consistent, uniformly shaped suppositories.
Now there's a really important calculation that goes with pour molding. See, when you add the drug powder to the base, it takes up space, right? It displaces some of the base. So, to make sure every single suppository has the exact right dose and is the right size, you have to calculate something called the displacement value. This is a huge one for formulation exams, so make sure you get this concept down.
So, you've made your suppositories. Are they ready for the patient? Not quite. they first have to go through a whole battery of quality control tests to make sure they're safe, effective, and up to standard.
This table lays out the most important tests. You'll check their appearance, their weight, and so on. But for your exams, I want you to really focus on two. The breaking test, which is basically seeing how tough they are. You don't want them to break during handling. And the melting range test. That one's crucial because it proves the suppository will actually melt properly at body temperature.
All right, let's bring it all home. What are the high-yield, absolute must-know points you need to walk away with for your exams?
Okay, here's your cheat sheet. First, know those 7 ideal properties of a base. Second, remember the major weakness of each base type: polymorphism for cocoa butter, being hygroscopic for the aqueous ones, and that low viscosity for the synthetics. Third, be able to list the 3 preparation methods: hand, compression, and pour molding. And finally, really understand what displacement value is and why we use it. Nail those points and you'll be in great shape.
And that's a wrap on our deep dive into suppository bases. But before you go, chew on this question. It's a great way to connect the dots between the properties of the bases and how you'd actually go about making them. Thanks for watching.